Hi, I'm Jason Moore of the Atari Projects website and the newly created Retro Projects website. Today I'll be giving you some tips for diagnosis, repair, and modification of vintage computers. Please feel free to contact me at morejh28@gmail.com if you have questions or comments. A little bit of background. I started with the Atari 400 and 800 home computers in the early 1980s. And I've had a lifelong love for the Atari and have been a collector and love using the original hardware, love using software and all the modern enhancements that come along with that. But I've also expanded out into other retro computers. I also work with Apple, the Radio Shack line, TI-99s, the Texas Instruments, Amiga, Macintosh, etc. I have a pretty extensive collection and have a lot of fun working with all the different machines and all the different computers that I didn't get to try back in the 1980s. Now, I had to pack up my collection a few years ago in a move and took 66 boxes to pack everything up. Of course, there's a lot of bubble wrap in there for protection, and I also thinned out my collection quite a bit before the move, just to give you a sense of the scale of my collection. I also do programming. This is a game for the Atari 2600 that I programmed in 6502 assembly language. So as you can imagine, these computers are getting quite old. In fact, the Apple II line started in 1977, which is almost 50 years ago, with the Atari coming out a few years later and a whole bunch of other computers in the early 1980s. Being 40 or 50 years old, these computers have components and chips, etc., that are failing. Nothing's sadder than turning on your favorite retro computer and finding out that it no longer works, and the panic, the anxiety that comes with that, and what are you going to do? And of course, nothing's sadder than the sad Mac face when a Macintosh fails to boot. So that brings us to diagnosis. So you have a computer that doesn't work. How do you figure what's wrong? You can't repair it. Do you know what the problem is? I actually like the diagnosis process. I love looking for clues and figuring out what is wrong with a computer. One of the first things I do is check the voltages to the computer. This is an Atari 800XL that has a 5-volt power rail that powers all the different ICs and components. And so you can probe with a multimeter the different parts of the board to check the 5-volt power rail to make sure that those voltages are correct. So for example, here I'm probing pin 8 of the 6502 CPU, which is where the 5-volt power comes into this particular chip, and you can see it's very close to the required 5 volts. As the voltages deviate from the set required amount, that can result in a non-working board. And if the voltages vary too much, it can actually short out the chips and destroy them. Now, we all love the original hardware, but unfortunately, the original power supplies that come with these old computers are also failing and are unreliable and can create unreliable voltages, leading to a computer that doesn't work. And in the worst case scenario, some of these old power supplies can actually deliver a voltage that's way too high for the computer and actually short out some of the chips. So I highly recommend modern power supplies, which can be purchased for almost all the different retro computers, Commodore 64, Atari, Amiga, etc. And there are even now power supplies being made that take USB. Just to give you an example of a voltage issue that I had on a Commodore 64 board recently, this particular 64 was giving a screen, a wavy screen that looked just like this. So I went to the Commodore 64 pictorial fault guide at pictorial64.com, where they have pictures of all the different screens and known problems that can lead to that malfunction. So for this particular screen, the fault guide said that it's this oscillator chip, this 74LS629, that is the problem. That chip resides in U31 here on the circuit board. This is the oscillator here that sends out the signal that's processed by the components here, and the VIC2 video chip, which sends out, I think it's a 1 megahertz signal to the other chips that provides the cadence, the tempo for the chips as they operate. So what I did was I removed this oscillator chip, I desoldered it, I put in a socket and a brand new oscillator chip, and that did not fix the problem. So I started testing the resistors and the capacitors on this circuit, all the other components. I couldn't find a problem. Took me a few days to figure out what was wrong with this board, and then I noticed that this voltage regulator here did not have a heat sink on it. These usually have a heat sink supplied by Commodore. And I took a pair of pliers and I grasped this voltage regulator with my pliers, and the screen immediately fixed. So what happened was the heat sink from the pliers cooled off this voltage regulator to the point where it was starting to provide consistent voltages to this oscillator circuitry here. I added some heat sinks onto this and was able to fix this computer, but that was clearly a voltage problem. The good news is there are modern solutions for diagnosing a lot of old computers. The Commodore 64 has a diagnostic cartridge and a dead test cartridge that you plug into the cartridge slot and can help you identify RAM chips and other problems, ROMs, et cetera, that might be wrong. The dead test is really interesting because it bypasses a lot of the chips. It just uses the CPU, it uses the PLA and the VIC2 video chip, and pretty much ignores the other chips. And that can get you to a point where you can diagnose a computer maybe a little quicker. This is an Atari 800XL that has a SysCheck2 module plugged in the back of it. With this blue thing's a power cable going into the 5-volt cartridge slot here. This is really good at testing the ROM and the RAM of the Atari and can pinpoint exactly which chips are failing. And I did use this to diagnose the failed RAM chips on a couple different Atari 800XLs recently. It was very useful. And then this is an Amiga 500, and the Amiga has what's called a diag ROM, or a diagnostic ROM, that you plug into. You remove the Kickstart ROM, which is the operating system here on the Amiga. You plug in this diagnostic ROM, and then it runs through a whole series of comprehensive diagnostic tests that can give you a much clearer picture of what's wrong with your Amiga board. So like I said, these exist for other types of retro computers, and you can usually get one of these for about $30, $40, $50, and can be a lifesaver in diagnosing a computer, and especially useful if you fix a lot of these kind of computers. One of the easiest tests for a bad chip is your finger. And when a chip shorts out and a 5-volt or 9-volt current is running through it, it can get very hot and to the touch. Now, a lot of the chips on a circuit board can be warm or even very warm to the touch. The VIC2 video chip on the Commodore 64, for example, is notorious for getting warm. But they shouldn't be so hot you can't touch them. They should just feel warm or very warm. But a failed chip with a short can get so hot that it'll burn your finger if you leave it there too long. So what I do is I plug in, turn on my circuit board, leave it on for a couple minutes, and then start touching each of the chips with my finger or my hand, feeling for hot chips. That's a good way to diagnose. There are infrared scanners you can use, or infrared temperature gauges. These can run $100. I actually don't have one of these and don't use them. I use the finger approach. But if you don't feel like touching your circuit board, you might invest in a temperature monitor of some sort, or infrared monitor. Another way to diagnose chips is with a chip tester. This is my TL8662 programmer tester. These are Chinese-made testers. Mine's about 5 or 6 years old. The new ones, the newest models can test over 30,000 different chips and come with software you install. And so basically, you put your chip in the tester here. You select which chip you're testing in the software, hit test, and it'll tell you if it's good or bad. So here's an LS06 logic chip. So basically what it does is it feeds the inputs and it knows what the output should be based on the logic circuit of the chip. So this one tested normal, and here's one that threw an error. I think this is one I pulled out of a disk drive. Oh, I should mention there are more expensive chip testers you can get that will test other types of chips like RAM chips and some other more sophisticated ICs. Those are expensive and can run $300 or more. It's good to get familiar with the circuit board through studying the circuit diagrams. This is a circuit diagram for the Commodore 64 that I got off zimmers.net. And this shows the pins of the various ICs and how they connect to each other. And as you're probing around and testing the circuit, this can be really useful for pinpointing exactly where a signal, a failed signal, or a problematic signal might be coming from. Continuity testing is something I used very recently to solve a problem. The green traces here on this circuit board can get damaged or severed, thus eliminating a signal between two ICs and bringing in, which could bring an entire computer down. And so this happened to me recently. I was desoldering some logic chips off a Commodore 64 board, and accidentally, I didn't know this, but I accidentally must have lifted a trace on the top of the board. And as I was testing each of the pins on these logic chips, making sure they were connected, for example, this one should have continuity with this one because of this trace here. And you can get circuit diagrams and test, test all the connections of all the different pins. So what I discovered is by testing all the pins here is that this particular pin was, and I knew from the circuit diagram, was supposed to be connected to the ground plane here. But on top of the board where I had installed a socket, the connection must have gotten severed. Somehow there must have been some damage. And so I put my multimeter here on continuity mode, turned on the sound, and when you have continuity, it makes a beep. And when I put one probe on this pin and one probe on the ground plane connection, I was not getting a beep and I was not getting a reading of continuity. So what I did was I put a blob of solder here to connect this pin with a via that was in the middle of this this rail here, thus reestablishing the connection on the bottom of the board, and that fixed this Commodore 64. A great way to diagnose integrated circuits is with an oscilloscope. This is my Siglent SDS 1104XE that I bought at Micro Center last year. You can also order these on Amazon. These are Chinese-made oscilloscopes. Now this one cost me $500, so they're not cheap, but they're very powerful and can give you a tremendous amount of information about what's going on a circuit board. Now this one's a little more expensive because it has 4 channels. So you can hook up 4 probes to 4 different pins on the circuit board simultaneously. I'll show an example of that in a minute. Other brands that are popular include Hantek and Rigol. These are also Chinese-made oscilloscopes. That all 3 of these models are very popular and seem to work really well. I've been very happy with mine. Now you don't have to spend $500. There are handheld models that you can get for less than $100. And so if you're not doing this regularly and maybe just need it a few times, $100 or $80 handheld oscilloscope might be just fine. And you can find videos on YouTube of people that have reviewed these and to find out what the strengths and weaknesses are. Now, when you're diagnosing with an oscilloscope, it's important to find a map of the different pins on each IC and what they do. So for example, this is the Sally 6502 CPU from the Atari 800, the Atari 8-bit line of computers. This is a nice figure I found at this website here that highlights some of the pins. So for example, this first pin here is the ground pin. Here's the 5-volt power pin coming in that I showed earlier. These are address lines for the RAM here on this chip. And so the idea is that you put your oscilloscope probe on each of these pins and you look at the signal, and you can study the signals to see if they're what you expect given what the signals should be. So here are some examples. Here is the pinout of the 6502 CPU for the Atari 800 XL. Pin 39 is a clock signal. So this is the oscillator signal, and you can see that it's measuring 1.79 megahertz. So that's what is expected for the Atari 800 XL. And you can see the regular oscillating pattern here. Again, this is the metronome or the cadence of the chips and how they communicate on the board. Now, if this were off or low or high, that would be an indicator that something's wrong with the oscillator circuit. Pin 33 here is D0, which is the first pin of the data bus. These 8 pins send data, 8 bits of data to the RAM chips and other chips on the board. And you can see this oscillating pattern of high and low. At the peak here is about 5 volts of electrical current, and then this is 0 volts down here. So if you were to see this data bus not getting to 5 volts, if it was stuck down here at say 2.5 volts, that would be an indicator that the chip was bad, or if it was always high, for example. Here's the read-write pin that tells the CPU whether it should be reading or writing data, and you can see it oscillates between 0 and 5 volts. And this is the address bus that specifies the address of the RAM where the data that you're sending is going, and it also oscillates between 0 and 5 volts. So this is the idea. You probe each of the pins. You're looking for these oscillating patterns from 0 to 5 volts, and things that look weird or off or different can be an indicator that something's wrong. So just to show you an example, here's a short video of my oscilloscope monitoring that D0 data bus pin 33 on the 6502 CPU, and you'll be able to see the voltages oscillate between 0 and 5 volts. Here's an example of all 4 channels of my oscilloscope hooked up to different pins on the 6502 CPU. And a 4-channel oscilloscope will allow you to see all 4 signals in different colors overlapping at the same time. So this could be useful for diagnosing what's wrong with the chip. Okay, so that brings us to repair. So hopefully by this point, you have applied these diagnostic methods. You have a pretty good idea what's wrong. Now you want to repair the board. So the first thing you need are tools, and these are the tools that I use to repair computers. We've already talked about the multimeter for testing voltages and continuity, and you can also use this to test capacitors and resistors, etc., diodes, all the different components of the computer. I have a Kawitz, which I like a lot. This is my soldering iron station here. I have a Weller, which is a German-made soldering iron I like a lot, has worked really well. You can adjust the temperature here with these controls. And then it's sitting here on a smoke eater. This is a Weller Shield Pro, which sucks the smoke generated by the soldering or desoldering through a carbon filter. And I also have a bigger one with a HEPA filter and a carbon filter running in my space to help clean the air. This is solder braid. This is a copper mesh that you can put between your soldering iron and a pin on the board or a trace on the board to remove bits of solder. The copper sucks it up when it's heated. This is for cleaning the tip of the soldering iron, some wire, some solder. A desoldering iron is really important for desoldering chips off the board, and I'll show you an example of that later. I have a Hakko FR301 that I like a lot. This is a hot air rework station that I'll talk about as well for helping get chips off the board. This is 99% isopropyl alcohol, which is very useful for cleaning the circuit boards. Contact cleaner for helping deoxidize chips and sockets, and that can help restore contact. Here's some white lithium grease. I use this for greasing the rails on a disk drive, for example. Obviously, screwdrivers, a wire stripper, a wire cutter, chip lifters are important for helping get the circuits out, tweezers, sockets. And then all of this is sitting on this gray mat here. This is a Weller, specially made Weller mat that prevents static charge and static discharge, which is very important because you don't want a static discharge can zap a circuit board and knock out these integrated circuits. So this is has a special rating to prevent static buildup, and you can attach yourself using a wrist strap here to this mat to help discharge any static. Now, one of the things that's really useful is reseating chips. As I mentioned, chips in sockets can get oxidized, and certain pins can lose contact with the socket. And so sometimes you can fix a computer simply by removing a chip from a socket, spraying contact cleaner in the socket that deoxidizes any oxidation buildup, put the chip back in, and restore content. And I actually fixed a Commodore 64 once that wasn't responding to the keyboard, and the cursor was not blinking at the basic prompt. And I did a lot of diagnosis on that particular board, and I actually fixed it when I reseated with contact cleaner the kernel ROM chip, and that fixed the computer. So it was just a bad contact. And this is a chip lifter for getting the chips out. Chips aren't always socketed. This is an Atari 800XL circuit board, and you can see most of the ICs are not socketed. They're soldered directly to the board. Looks like only these chips here are socketed. So that can make it difficult if you found one of these custom ICs was bad using your oscilloscope, using your temperature test method, for example. You can't just pull it out of a socket, so you got to desolder the chip to get it out of there, and then install a socket and then put a new chip in. So desoldering takes a little bit of practice and takes some special hardware. I mentioned the Hakko FR301 desoldering iron that I use. I highly recommend using a desoldering iron, and the Hakko is a common one that's well liked and good quality. And so here's the basic idea. You have a pin with some solder. This has a hole in it. You can set the temperature on the desoldering iron, and once it's at temperature, you put it over the pin, wiggle it around for about a second or two. That melts the solder, and then you push this button here that turns on the suction, and the solder is sucked through the heated tube into this little plastic chamber here where it cools and hardens. And so this is very effective at getting solder out. You can see these pins here of this RAM chip where I've removed the solder. This little plastic cartridge pops out, and you can clean the solder out very easily. Now on the top side of the board, even after you've desoldered the bottom, there's still often some residual solder that connects the pin to maybe the trace up here. And if you just lift this chip out thinking you've desoldered it, you can actually, if it's connected, you can actually lift this trace and then from the board, and then you're in a position of having to do some repair on the board. So a good method is to follow up with a hot air rework station. This is a Yeehaw that I have. You can set the temperature and the air speed. I was a little concerned when I bought this that it might be noisy, but it's actually extremely quiet and it works very effectively. So what I do is I have a tool here for applying a very, very light amount of pressure to the chip as I heat it with hot air. So you circle the chip with the hot air, that melts the solder, and as you gently lift, the chip should come loose without damaging any traces. Now, unfortunately, this does take a little practice, and it is possible to damage a board. And I'm showing you an example of some of my not my best work. I was repairing a Commodore 64 board and had decided to socket a bunch of the chips. And so I was doing a lot of desoldering and a lot of soldering. And I think I got in a hurry and did not clean my desoldering iron, and it wasn't suctioning very effectively. And you can see there's still a lot of solder stuck in these traces here, these solder pads. And so that's an indication that the desoldering iron is gummed up and not running efficiently. And then when I tried to lift this chip with hot air, it actually lifted a trace and damaged this trace here connecting these two pins. I present this example of a little bit sloppy work on my part. I should have taken my time. I should have had a clean desoldering iron, and I think I could have achieved a much better result here. But what I did was I went ahead and got rid of the remaining solder, put in a socket here, but I did not trust this connection. So I flipped the board over and put in a bodge wire connecting these two pins to make sure that they were indeed connected, regardless of what was happening on the top of the board here. Here's an example of some RAM chips that I desoldered out of an Atari 800XL board. In this case, I did a nice job of getting those chips out in a clean, effective manner. These are Micron technology RAM chips that were common in the Ataris and the Commodores. These are notoriously bad. This company cut a lot of corners and made cheap chips that failed very frequently. This particular Atari 800XL had several MT RAM chips that were bad, so I went ahead and desoldered them all. I soldered in sockets and then installed new RAM chips here. The sockets make it easy to swap chips in and out if they fail later. Now, when you're soldering sockets in, you want to make sure they're flush to the board. And common best practice is to solder one pin on each side while you're holding the socket to the board. Let that cool so that it's make sure it's flush. And if it's flush, go ahead and solder the rest of the pins. What you don't want to do is solder all the pins, find out it's crooked or offset, and then have to desolder the whole thing again and solder it back in. Now, a common problem with retro computers from the 1990s is the need to replace leaking electrolytic capacitors. So 1970s and 80s computers use capacitors that were made of better quality and they last longer. In fact, I only had to replace a capacitor on an Atari or a Commodore from the 1980s once. But in the 1990s, for whatever reason, they started making cheap electrolytic capacitors. I guess they thought computers were becoming more of a disposable commodity and nobody was going to need those computers after a couple of years. And they could make capacitors that had a lifespan of 10 years instead of 50 years. And so computers from that era include the things like the Macintosh Classic 2 that I have here and my Macintosh LC. These were made in the 1990s. Earlier classic Macintoshes like the 128, the 512, even the SE are fine and use the better capacitors. But these later models use these leaky capacitors and boy, do they leak. Other computers of this era include the Amiga, like the Amiga 1200, even PCs, certainly any Macintoshes from that era. Atari STs can leak as well. So a lot of the 16-bit computers, in other words. So here's an example. This is the circuit board from the Mac LC I showed on the previous slide. This one actually has an LC2 motherboard for some reason. But these are the surface mount electrolytic capacitors on this board. This is a very common scene for all of these Macintoshes. In fact, my Macintosh Classic 2 that I showed on the previous slide has the same problem. And you can see all this gunk that has leaked out of these capacitors and is finding its way over here to these integrated circuits. This is boric acid and other nasty stuff that leaks out of these capacitors. And every Macintosh I've looked at has had these leaky capacitors. They all leak. So don't assume that you might get lucky and they don't, because they do. And they have to be replaced, and all this stuff has to be cleaned up. So what I do is I remove these surface mount capacitors. I use a method called the twist method, where I take a pair of needle nose pliers, I apply some downward pressure and twist the capacitor back and forth. And when you have acid on the board like this, the legs that connect the solder pad to the capacitor get weak, and they just twist right off. What you don't want to do is pull up, because you don't want to remove the solder pad from the board, because then you have to do a repair. Some people use hot air, like I showed it earlier with a hot air rework station. That works well too, but you have to be careful not to damage the components nearby. So the twist off method I've used several times, and it works really well. These chips just pop right off. So once you get them off, then you have to clean the board. And the first thing I do is I take a soldering iron and get the legs off. So if you heat this up and then just kind of push it, these residual capacitor legs just pop right off, and you can clean your soldering iron tip and get them off. So once you have the legs off, then you want to clean it. Some people use vinegar, which I don't understand. Vinegar is an acid, and acid on acid just doesn't make sense to me. So I use soapy water, which a lot of people use. So I take any socketed ICs out, and then immerse the board in soapy water, warm soapy water, and then I use a toothbrush to scrub all this stuff off. Soapy water is nice because soap is a base, so it neutralizes the acid to some extent. So I scrub and scrub and scrub and get all this stuff off. And then I go over the solder pads with some solder braid, this copper solder braid. So you put that on the pad, put your soldering iron on top, and very gently go back and forth. And it soaks, as it heats, it soaks up the solder. Then once I have the solder removed, then I go over the board with 99% isopropyl alcohol to remove any residual acid or leakage that might have survived the soap bath, and to remove any of the residual solder that's on there. And you can see here, this is the same board before and after, and you can see these nice shiny solder pads that are ready for new solder and new components. Sometimes they get this black crusty stuff on here. I just take a sharp point and scrape that off gently to reveal the shiny solder pad underneath. And here is that Mac LC board that I just showed you that got cleaned with new tantalum capacitors. What I do is I put a little bit of solder on each pad. I hold the tantalum down, heat one pad, and then heat the other pad. And that's all it takes to put these on. I order my capacitors from Console 5. There are several different places that will sell capacitor kits. I've only used Console 5, which works pretty well. You can see the tantalum replacement capacitors for that Mac LC only cost me $6, so they're not that expensive. Here's a list of all the capacitors, their microfarad ratings, the voltage ratings, and their placement on the LC2 logic board that I repaired. These are kits that I ordered for my Nintendo 64, my Super Nintendo, and my Atari Jaguar consoles. These are all from the 1990s and have leaky capacitors, so these are projects for a future time for me. Now, when I fixed that Macintosh, I wasn't done with just the logic board and the circuit board. Turns out the power supply also has electrolytic capacitors on it. This is the power supply for that Mac LC. Actually, I have two LCs that I recapped. These are the power supplies for both of them. This power supply was actually not even working. It wouldn't power up. And you can see in the middle here, the gunk that has leaked out. All these capacitors have leaked. And so I had to remove them and clean this all up with isopropyl alcohol, get it nice and shiny, and then solder in new through-hole capacitors using kits that I got from Console 5. And that this power supply, once recapped, was working fine. Okay, so that brings us to modifications. The good news is there's a lot of modern modifications that can fix or enhance the functionality of our retro computers. There are a lot of modern replacement chips, which are getting harder and harder to find. This is a Commodore 64 that I repaired. It had a bad VIC-2 video chip, and the VIC-2 video chips are getting harder to find, and you might need to spend $50 to $100 to get a replacement. So the good news is there are modern replacements. This is a something called a Kawari that has an FPGA on top here that emulates the VIC-2 chips. It plugs right into the socket, gets the signals, processes them, sends them back out for the video. This is a wonderful replacement. These are about $100. You can get a $150 model that's a little bigger and has an HDMI slot on it so that you can get HDMI out of your Commodore 64. So these are really nice replacements. Here's another example. This is a replacement board for the 6581 SID sound chip for the Commodore. These are also highly sought after and can cost upwards of $100 to replace. This is a Raspberry Pi Pico solution that emulates the SID chip, and these cost about $30, and you can actually order the components for this and make it yourself for about $10 or $15. So this is an inexpensive replacement for the SID sound chip. It's not quite as good, but if all you're going to do is play games, it's probably just fine. And here's a Commodore 64 board that has a Kawari VIC-2 video replacement. It has this SID kick Raspberry Pi Pico SID sound chip replacement, and it has a PLA replacement. The PLA is the chip on the Commodore that manages all the signals to the various chips. These are built using two GAL chips, which you can get very inexpensively and program using a programmer and plug in and replace the functionality of the PLA. I've also added to this board, I've replaced the RF module here. So this is the circuitry that processes the video signal that comes out of the Commodore. And this is one made by the Retro channel, which works really well, gives a nice clean signal. And it has an S-video connector here, which allows you to get S-video out to an HDMI converter very easily. This produces a very nice signal. The combination of this Kawari replacement chip and this new RF modulator produce a nice clean signal. You can also get what are called CPU accelerators for some computers. This is an example for my Amiga 500. This is what's called a Pi Storm, which replaces the 6800 CPU here. You take the CPU out, you put the Pi Storm in. This has FPGA circuitry on it that processes the CPU signal. And then you can put in a Raspberry Pi, in this case a 3A that plugs in here. The Raspberry Pi emulates the CPU signal, and you can actually select what CPU you want to use, whether it's a 68,000 or a 68020 or 030 or 040. So you can get a faster CPU out of this, and you can take advantage of the onboard memory of the Raspberry Pi. So this accelerates the CPU, gives you more RAM, and does other interesting things, as I'll show you in a minute. And just as a side note on this particular Amiga, I also installed sockets and installed new RAM to expand the chip RAM from 512K to 1 megabyte of chip RAM. This is the RAM that all the ICs use, including the Agnes video chip here. So this is that same Amiga 500. And one of the really interesting things is you can run a modern operating system on the Raspberry Pi, feed that out through the Raspberry Pi HDMI port to a screen that's shown here. This is running the Caffeine operating system, which is a modern OS. And from here, you can launch games on the Amiga that run on the original hardware. And the game video goes out through the RGB port. I've got this going out to a SCART converter, to an HDMI converter, a RetroTink that converts it to an HDMI signal. And here is a game running on an LED screen. So you can have both of these running at the same time, which is pretty cool. All right, so finally, let me summarize with some tips. Number one, have fun. As your skills improve, you will have fun. I started learning how to do all this repair and modification stuff, diagnosis, about a year ago. And my skills have improved tremendously over the course of the year. I've fixed dozens of computers and disk drives now and done a number of modifications. I've fixed some computers for some of my friends. So have fun as your skills improve. I find it really fun to work with my hands and repair these computers, and I love the excitement of actually getting one to work. Take your time. It's easy to make mistakes. Don't rush it. I showed you the lifted trace that I had, which probably came from me being in too much of a hurry. Number three, invest in good hardware and supplies. Yes, it's expensive, but if you're going to do a lot of this, you want a good soldering iron, a good desoldering iron, a good multimeter, etc. Number four, YouTube is your friend. I learned how to do all this, most of this on YouTube. And I'll show you in my last slide some of my favorite YouTubers that I learned a lot from. So watch a lot of YouTube videos, and then when you feel comfortable, try the repair or the modification. Build a community, get to know people in your area that have skills that you can draw on, that you can talk to. Go to vintage computer festivals and talk to people. Number six, you'll make mistakes. Everybody makes mistakes, even the experts make mistakes, and learn from them. I've gotten better because I've done things wrong. I've had to fix them, and I learned not to do those things again. Number seven is mind your health. The fumes that these things can generate may not be good for you. So that's why I invested in the smoke eater and the HEPA filter with the carbon filter to clean the air. And so take care of your health, and uh, that will help you have more fun. Number eight, as you learn how to do these things, share your projects, do a blog, do a YouTube video, teach others, pass on the knowledge. Number nine, have a budget. This can get expensive. There are a lot of, for example, there are a lot of Raspberry Pi devices that are coming out. It's hard to keep up with all the virtual disk drives and CPU accelerators, et cetera. And and each of them can cost 50, 100, a couple $100. It's easy to spend too much. So definitely set yourself a budget and pace yourself. And finally, clean your desoldering gun regularly. I have to keep reminding myself of this, and I think that's what led to that messy work shown here on the right with the solder left in the holes and the lifted trace. I just got in a hurry and didn't take care of my desoldering gun. So finally, I want to acknowledge my favorite YouTubers, Adrian's Digital Basement, the Retro Channel, and Jan Beta. Uh, all have hundreds of videos on how to repair old computers and troubleshooting, great tips and advice and examples. And so I highly recommend these three. There are others as well, but these are my three favorites. So that's it. I hope you get a lot out of these tips. And again, I'm from Atari Projects, and my new website's Retro Projects, where I also document what I'm showing in this video and other things. And I'd love to hear from you. Reach out to me either on YouTube or through my email here, morejh28@gmail.com. Send me questions. I'll do my best to answer them or give me comments. There are a lot of different ways to do this, and my way may not be the best way for you, but that's what the YouTubers are for. Everybody does it a little differently, and you can decide for yourself how you want to do it. So thanks, and good luck with your retro computers.